Welcome back, geometry students, to section 2.6. Today we're going to be talking about proving angles congruent. We're going to kind of continue off of the proofs concept and build off that just a little bit. Okay, so the first thing we have here is a theorem. We've been talking about theorems a little bit and their necessity to make proofs. And you've heard of Pythagorean theorem and some other theorems, but what does it actually mean? Well, it's a conjecture or statement that you prove. So the ones that you've seen have already have already been proven. There, you prove true. Okay, I think my pen's a little, there we go. It's a little too small. There we go. So there's our theorem, conjecture, statement that you prove true. Now let's talk about the vertical angles theorem. And we're actually going to prove this one. It's fairly simple to prove. So the first thing we need to do is we need to write in some numbers to differentiate these angles. As you can see here, we have two intersecting lines, and it creates four spaces for us. It creates 1, 2, 3, and 4 different angles. Okay, and what we're going to show is we're going to show that angle 2 is going to be equal to angle 4, and angle 1 is going to be congruent to angle 3. I said equal measure, congruent, okay, kind of interchangeable terminology there. So these two angles will be congruent to each other, and notice how they're positioned kind of like opposite each other, and then these two angles are congruent to each other. Again, positioned opposite from each other. Okay, that's a very important distinction. And we're going to kind of go over nuances in later sections of just what are vertical angles and what are not vertical angles. But they need to share a common vertex and be on opposite sides. And they also share opposing rays. And I think I'm going to talk about that in Chapter 1. So if you want to revisit that, go ahead and check out Chapter 1. So let's go ahead and get started with this proof. Angle 1 and angle 3 are vertical angles. Let's prove 1 is congruent to 3. We can't just say, oh, it looks like it. Let's make a proof. So here, let's go ahead and get started. The first step is we're going to say angle 1 and angle 3 are vertical. And we're going to kind of shorten things just to make it easier to write. So we have angle 1 and angle 3 are vertical. What's our reason? This is because it's given. It gives us this information. Okay, so this is its own separate problem. We don't know this yet. Okay, we're trying to prove this, but we're just kind of establishing the givens and moving on from there. What's next? Well, we can look at our picture and kind of see that there's certain information that we can derive from this picture, from this diagram. And one of it is angle 1 and 2 are supplementary. Angle 1 and angle 2 are supplementary. Why is that? Well, let's take a look. Why are these two supplementary? Well, if we draw, let's get this highlighter and let's make it much smaller. Here we go. If we draw this line here, notice how 1 and 2 are both part of this line. Okay, so what does that mean? Well, if they both share a line, we know a line is 180 degrees. That is 180. So they must add up to 180. Okay, that's just because they are on a line. Now, what is that called? Before we get to the 180 concept, I kind of jumped the gun. We know that these form a linear pair. Oh, sorry. Angles. There we go. 1 and 2. No, sorry. Angles that form linear pair, and we talked about this a little bit last time, are supplementary. You could also say something like definition of linear pair. So angle 1 and 2 are a linear pair. You could also use an extra step. You could say 1 and 2 are a linear pair, and then the second one is and I guess that would be from the diagram. You could say derived from the diagram, shown in the diagram. And then the second one, they're 1 and 2 are supplementary. Angles that form a linear pair are supplementary. Okay, so this one just kind of combines two different things at the same time. But because of this, we can also say angle 2 and angle 3 are supplementary for the same reason. Notice how 2 and 3 are on their own separate line. I'm going to move this up a little bit. Okay, and again, it's the same reason. So I'm going to go ahead and show that it's the same reason. So I'm going to do quotes like that so I don't have to write it all out again. It saves me space too. You guys can do the same thing. So angles that form linear pair are supplementary. I use quotes to indicate it's the same reason above. Okay, moving on. So if we know that they are supplementary, what does that mean? Well, we know that we can say angle 1, I don't know why I switched to blue now, but I mean blue and red, and angle 2, oops, I need an addition sign. Angle 1 plus angle 2 equals 180 degrees. And why is that? Well, we can just say definition of supplementary angles. Supplementary angles. Okay. By the same token, copy, paste, we know, and I'm going to have to move all this up. Give me a moment. Okay, let's move this up. Boom. Move this up. Boom. Move this up. Okay, just trying to create some space here. You can fast forward this part. It's not very important. Okay, by the same token, I just copied and pasted it, but the reason why I'm doing that is because I can write angle 3 here now. Okay, and I didn't show this earlier, but you can see here that clearly 2 and 3 are on its own linear pair. Okay, so this would be their linear pair. They're on a line system. Okay, now they also have a sum of 180, and that's the same reason, definition of supplementary angles. Now, notice that we have here, we have 1 and 2 add up to equal 180, 3 and 2 equal 180. We have essentially a transitive property, almost like syllogism. If angle 1 plus angle 2 equals 180, if 180 equals angle 2 plus angle 3, then angle 1 is equal to angle 3 and 2. So it's almost like a syllogism statement. That's kind of how the transitive property works. So what we're going to do is we're going to copy paste 3 and 2 equal to 3 and 2. So copy, paste, okay, and then I'm going to copy paste this guy, copy, paste. So then we have this statement here. Transitive property, we took the information above and connected it. It's almost like the substitution property. And honestly, I wouldn't even mind if you called this the substitution property, because what you're doing here is you're substituting this in for 180. Usually transitive property includes taking the whole side of an equal sign and plugging that aspect in, or substitution property is just one term. Now, what are we doing from here? Well, we're trying to prove, let's keep in mind our objective. We're trying to prove 1 is equal to 3. So what can we do from here to prove that 1 is equal to 3? Or congruent to 1 and 3? Well, you see here we have 1 equal to 3 almost isolated. The problem is we have this angle 2 on both sides. So how can we get rid of that? Well, if you were to do this with math, we'd have angle 1. Let me use a different color. You'd have angle 1 plus angle 2 equals angle 3 plus angle 2. What would you do? Well, you just want to get rid of angle 2 from both sides. And what happens? You get angle 1 is equal to angle 3. So that's really all we need to do. It's just algebra at this point. So we can just subtract angle 2 from both sides as I demonstrated here. So eventually what I showed is we get angle 1 equals angle 3. And what do we use? We use the subtraction property prop of equality, EQ, equality. Now, this last step is kind of unnecessary, but in a sense it is necessary, is we can say, because we said that these two angles are equal to each other, and actually it says the measure of these angles. All of this should be the measure of these angles. I forgot to write that in. It's really kind of nuanced. I wouldn't worry too much about it. It's, for me, for my students, as long as you're getting the angles, that's the important thing. But anytime you're talking about measure of angles, that's what's equal 180, not the actual angle itself equals 180, but the measure of the angle. So once we get here to this step, we can say angle 1 is congruent to angle 3 because angles with, that's what that word means. This means angles, that abbreviation, with the same measure are congruent. The main step here is that you first recognize that these are supplementary angles. Second, that you can set those supplementary angles that they're equal to each other to equal 180. Then that they're equal to each other. You can subtract 2 from both sides, angle 2, and that you get that the angles have the same equal measure. Okay, that's an important thing. I would freeze this screen, copy this down. Okay, now that you're done copying it down, let's move on. Congruent complements. Now, I would not worry about memorizing this, but this is just kind of some extra information to show you how you can substitute values for one another with angles. So this essentially says if angle 1 and angle 2 are complements, so if angle 1 and angle 2 are complements, and angle 3 and angle 2 are complements, and complements means the two angles add up to 190, then angle 1 is congruent to angle 3. This just means if 1 and 2 add up to 90, and 3 and 2 add up to 90, 2 is the same angle, okay, reflexive property, it's the same angle, so therefore they have to be equal to each other. 1 and 3 need to be equal. Now we have congruent right angles theorem. Congruent right angles theorem, also similarly easy. If we have angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. So right angles are congruent to each other is the main idea here. Again, you don't need to memorize the names of these. It's just kind of additional information. So last one, angle 1 is congruent if angle 1 is congruent to angle 2, and, oof, that's a rough hand, and angle 1 and angle 2 are supplements. That means they add up to 180. Then the measure of angle 1 is equal to the measure of angle 2, which is both equal to 90. So they have the same measure, which is 90. Just some, I'm not too enthusiastic about these. I hope maybe it came out in how I was talking about it. But I just wanted to give this information in case you see it in a problem. Hope you found this helpful, and thank you for watching, everyone.